Hey, hi guys, this is Salim. Once again, welcome to my channel. Hope you're all doing great, guys. So, in this video, I am going to tell you about the implementation part for linear regression, guys. So, last video we have saw about regression, like the types of regression and everything. So, if you missed to watch that video, guys, please do watch. The link for that video is in the description. You can find it there. And guys, I'm just taking only the sample data and applying the linear model in order to make you all aware of what actually a linear model is. How can we approach a linear model for a given problem data input set, guys. Anyhow, after this, I'm going to show the implementation part by taking real-time data also, guys. We're going to see. So let's get started. So guys, yeah. Uh, This is the linear regression, guys. I have already written the code. I just don't want to make your time waste. Please pause the video, guys, if you need, and you just practice it, guys. As I've always been telling that practice makes man perfect. So please do practice. So guys, these are the libraries that we are importing. So pandas, numpy, so pandas is used for preprocessing and numpy for data storing in arrays and matplot library for data visualization and sklearn. This is a very important library, guys. This library contains all the models that we required, and so this is imported. I just want to make sure where my file is present, the path. And the first step we are going to do is we are going to read the data. So for that, pandas is going to help. So this is the way we are going to read the pandas dot read Excel, since my data input sheet is Excel format. And guys, after reading this, we are going to check the present of null values, whether the null values are present or not, and also the alphanumeric values. So if you don't know how to do that, please do watch my pandas video also, guys. And after all checking that, then we are going to display the actual data of from the input sheet. So this is the data. So there are two columns and we do have 5 rows. Next we are going to find out the correlation coefficient, guys. So correlation coefficient means like the linear regression actually defines as it's a statistical method in order to find the relationship between two variables, that is independent and dependent, which means linear regression mainly focuses on identifying the relationship for the given data, guys. So it will identify the relationship, how strong it is. So for in order to find that relationship, so this is the method correlation, so which will gives a good relation whether between two variables, how they are correlated to each other. And for the given data, if we plot a graph, so this is the way how it looks. This is just for the given sample data, guys. Just we have to read the data, right? So that sheet contains some data, and that data, if, in order to display in a graph format, so this is the way. So after that, since we know that the linear regression formula is y equal to mx plus c, where m will be act as slope and x will be as the predicting value, c is the intercept. And guys, this y, so this y only we are trying to find out, guys, because as I told, variable independent and dependent. So this x will be always independent and y will be always dependent. So in order to get y, we need x. So x should be predicting value, guys. So whatever the value we are going to predict, we are going to substitute here in x, and we are going to finally get the y value. So this is another way how we are going to display for the given input data sheet. So this is the box plot graph, and so we already find the correlation. And guys, another thing is, whatever the data we have received or we have read, so we need to first make the data in a perfect way, guys. As I told, pre-processing is the main important part, so pandas is going to helpful for that. So after pre-processing, next we are going to make the data in a data frame format. So everything should be converted into data frame, and pandas will helpful in order to do that. So this is the way we are going to convert into data frame, and we're storing some variable pr and square. So if we display, this is the way how it is going to be look. And after that, now the final thing is we are going to apply the model. So we are going to apply the model for the data which we have converted into data frame. So for that, as I already told, sklearn is a library where we can find all our models. So the linear model we are going to apply. So this is the way how we are going to apply linear model dot linear regression analysis method. So now for the given data, we are going to check whether the data is fit for linear model or not. So this is the way how we are going to check linear model dot fit for the data PR and square. PR and square, why? Because I have already told you that everything is going to be counted in data frame, and that data frame data is going to be take furtherly, and we are going to apply whatever the functionality on that. So here you can see the PR and square. So for this PR and square only, I'm going to apply anything regarding checking for the linear model, guys. So yeah, so on seeing this, it is okay, it is fine, it is fit. Next, coefficient. So coefficient here is, guys, um, the linear equation formula, or else the straight line equation is y equal to mx plus c. So here m actually slope, right? So which will be the coefficient here in our case. So and c will be like intercept. So we are finding the coefficient, guys, coefficient of for the given all the data, and also intercept. And one more thing, guys, here we need not to apply any formula. Actually, in order to find coefficient, we do have formulas, so which I have already explained in the previous video of regression analysis. So by default, we can have this predefined or built-in function, so we can use this directly, and we're going to get. And if we need to check how good accuracy it is, so this is the score function where we are going to pass our data frame data PR and square where we have stored that, and you can check here, guys, 0.9584. It doesn't mean that it is less than 1. It means that if you divide it by 100 I mean 100, I'm sorry, if you multiply into 100, we are going to get this 95 point something percentage. And guys, now final thing, whether we need to check it is going to be giving good accuracy or not. Like if you want to predict something value, whether this linear model is going to give this prediction value accuracy or not. So suppose I need to find out 3300 among the given input sheet values, which is actually not present. Now this 3300 I am going to predict by applying the linear model. So model dot predict, since the model I have already stored here, yeah. So I already store this model by checking the goodness of fit for the given data. So model dot predict for what? For this value 3300, which is stored in price name, and obviously it is giving the range or the value. So in order to check clearly, guys, we can do mathematically this. So we can plot a graph, and we can draw a line when we can check by applying the formula. So anyhow, we are going to get approximately this. And if you want to predict more number of values, so we are going to take a list of array, and as I told, everything is going to be converted in data frame. And for the data frame, we are going to apply this linear model to check whether it is exactly okay or not. So applied model, and I predicted. So the prediction values for these are, yeah, here in the area, as you can see. Guys, I mean, it will be a little bit problem for me to explain you or to show you. I'll just come up sometime by taking a graph also. I'll show you a demo. I'll show you the mathematics behind this also, guys. Like this 547,243 point something, this is all we can solve, guys, by taking the formulas, by applying the formulas, and by taking a graph as an example. So if you draw a line in between the points, we want to predict some other point. So uh, for me here, it is very difficult to show you, but I'll just come up with some other class, some other video where I can show you entirely the mathematics behind the linear model. So for now, you just assume that it is giving a good prediction only. So similarly for y also, Now for both x and y we have concatenated and displaying in this row and column wise like matrix. Now the final thing is, for we have taken the data, we have applied the linear model and we have predicted for some values and we get some prediction, and all this combined we are going to display in a graph. So now the displaying graph is here. We are visualizing the data what we have predicted. So this is for normal input data, guys. We have to read the input data sheet, right? For that we are going to display. So if I just uh, comment this and if I run, we are only going to get this graph, guys. In the initially what I showed you, yeah, this graph we are going to get. And after that we are going to draw a regression line. Regression line for what? Regression line for the data which we predicted. So here we have predicted already. Yeah, where it is. Yeah, for this y, as I told you, y equal to mx plus c. So always we are predicting, I mean we are wanting the variable y only. Y prediction we are wanting based upon x. So similarly here we are making x as a price, guys. X as a price. So based upon the x applying, we are going to get y. So we are predicting x because whatever the values we are giving, these values are belongs here in the middle. So uh, we are predicting x as obviously. So if you plot, so we are going to get this line. So you are seeing here red line, right? So this line is actually for this. Let me show you by commenting. Yeah, this is the line, guys, actually. Now after that we have predicted some more values, right? Like 3300 and these value 2700, 3500, 4500. For these values, if we want to plot a graph, if we want to plot a regression line, how it will be? Yeah. So the kind of points like scatter. So for what price and square feet, we are for those values we have predicted, right? So I'm giving color black. Now I'm running. Yeah, you can see here the black color. So this is the black color for which we have predicted the values plotted here on the regression line. Now suppose if you want to plot or if you want to show the points in a scatter way, we can also use in a method those values. Yeah, so x and y. Yeah, the x has 2700 and 3500, 4500. These values if you want to show on a graph, yeah, you can see here 2700 which lies here somewhere. Similarly 4500 which is not actually present in the given input dataset, but we were predicting the future. So 4500 which is predicted, which is in blue line. Mm, so similarly with the 3500 which lies here, yeah, which lies here, this is the point. So like this, guys, we are going to plot and we are going to predict the values. So this is just simple, guys, but in a real time we are going to use a train, test and split method, where we are going to divide the data in training and testing and applying this any model on the training, and then we are going to apply testing data set on the training data set. Like here we have predicted some price, right? There we are going to predict by applying the testing data over that training data, whether how accuracy it is going to give for the given for the trained data uh, in the perspective of testing data. So anyhow, I'll come with some other video by taking a real-time example. So guys, hope you all enjoyed this video and also know what actual linear regression is. So please do like, share, comment, and don't forget to subscribe, guys.